Hello YouTube, this is Ready Set Exploit, and we're gonna be doing Chrome from TryHackMe, which is a challenge I created that involves reversing a Windows.NET binary and then decrypting the passwords that are stored inside the Chrome AppData folder. So the idea for this challenge was inspired by this particular article that I'll show in a bit, and I'll show you how to solve the challenge using both Windows and Linux. It starts the beginning. It's actually considerably easier in Windows, and then it can get a little tricky, but not too bad. And the opposite is if you use Linux. The beginning is definitely a little bit trickier, but towards the end is actually a lot simpler. So I'll show both ways just so that you can see that you don't. While I do favor having a Windows VM for forensics, especially Windows forensics, there are ways you can get around it if you only have a Linux VM. So without further ado, I'll go ahead and get started. So first thing is we are given the Chrome files.zip. So let's go ahead and unzip those. And we are given a PCAP file. So let's go ahead and open this Wireshark. And first thing we notice is a lot of SMB requests, right? So let's see some authentication and see what we have here. So get info request, request file, anything else that stands out. Let's see, validate. So right here we have a user called hacked. No, we're accessing, let's see, hacked. So it looks like some kind of, well, this wouldn't be the name of a share, but this is probably the attacker's share. And then see a lot of traffic, and then if you go down we'll see we notice create request file. So a lot of file requests. So the first thing to notice is that this traffic is not encrypted. Typically it would say SMB encrypted. This one is not. So when that's the case, we can go to file, export objects, and look at the SMB traffic, and we'll notice right away two things that we can extract. First is this exe file, right, and these encrypted files. So let's go ahead and extract these. Save, and then this one, which is 75 megabytes. It's a lot bigger than the original one. So encrypted files, and we can close this, and that pretty much does it for now. We can close this because the rest of the traffic seems to be mainly just SMB. So we can verify that if we just go, we see everything is just yellow. There's some red here, probably the transfer, but everything pretty much it's all happening in SMB. A lot of file requests. So let's see what else we have. We have encrypted files, which is just blob scenes. Otherwise it wouldn't be encrypted. Let's see, head. Yeah, so it's probably just a lot of encrypted junk. Let's look at the transfer files. We have a .NET assembly. Now, if you're not too familiar with reversing, this means it was typically means it was built using C#, but we can confirm that if you were to just Google this. Get a lot of results, but if you, this one article puts it pretty well. Let's see, from a challenge, this is pretty much what we have. So it's a .NET assembly, so we can run the binary, or we can use this program called DNSPy, which is a .NET compiler and debugger. Or you can also say install the VM, and it shows that you can review the code pretty cleanly. So that's one way to do it. I'm going to show how to do it with DNSPy, and I'm going to show how you can do it with Ghidra if you don't have a Windows VM. So first, let's go ahead and create a server here. I'm going to go ahead and transfer this over. Let me go ahead and switch VMs really quick. You should see my Windows VM now. So I'm going to call my file drops here. I'm not going to turn off Defender yet. I don't need to. I have an exclusion, but you never know. So I'm gonna actually just download this. So let's see, transfer.exe, app file transfer.exe, and let's see. Let's go ahead and use DNSPy, and I already have it saved. Although it says it was 32, you can try both, but this one happens to be 64-bit. DNSPy will just tell you if it doesn't work, especially if you're debugging. And there we go. So we have everything. You should have the file here. We could step through it. Fees, like the headers, the references that it uses, right? We could right off the bat see there's AES and crypto, right? And if we go over here, we have module program. Okay, this is just so you kind of can go through these. There's nothing here. We have program, and you go through these: public program, main. So that's the main program right here. So we have the class program, and we have, so it's a very, very small program. We can actually see that if we go, oh, right, so why do I have two open? So if we go to properties, it's it's small kilobytes, right? It's a very small program, and let's go ahead and examine it. So it looks like it sets a, let's see, a string, bytes, so bytes 2. And we have this right here. So this looks like, if we're dealing with AES, probably the key, probably the IB, right? And let's see. Oh, I didn't mean to do that. And we have AES. Let's see. So it took this file, the zip file. So we would like to eventually know what this is. Reads it. AES, creates the AES key, ready to go, there we go. Key is set to bytes, and IB is set to bytes too, so like we guess, key and IB. And it encrypts, it uses AES. It doesn't say which one it uses, where it's CBC, ECB, but that's pretty easy to figure out. Then, look, that's where the encrypted files came from. So it encrypts it, saves it, right, all bytes, path 2, which is here, bytes 3, which was this array here, see memory stream to array, so that's what it writes it to. Files encrypted and saved successfully, and that's it. So just encrypts these files. So we at least have the keys here, right? So let's go ahead, and that's pretty much all we needed. So very straightforward debugger gave us what we needed. So let me go ahead and switch back to my Kali VM, and let's go ahead and write AES values. So go ahead and copy that over. Key IV there we go. And let's go ahead. Now you'll be tempted to think this base 64, you can try it and you'll know right away if it is or isn't. Right? So let's go ahead and use CyberChef, simplest way. Input my file. I'm gonna go to Chrome, encrypted files, and we're gonna do, see, it loads it, bunch of junk, AES. So first, we know it's not hex. So let's try this. We'll try the first one. There's different modes, but we'll try this one. Input is raw, output raw. Okay. So let's say we think it was base 64. And do this. So it gives us an error. So let's try UTF. Let's see if it's just random strings. And it's taking a second. And there we go. We have the PK header and we have some strings. Let's see. Can it detect it? See, come on, CyberChef, you can do this. Aha, it's a PK zip archive. So it does detect it, so which is what we established before. So now what we can do, another way you could verify it, So right off the bat, we guessed that it was CBC. You could have kept trying until eventually you hopefully got something. Because if we try CFB, it most likely shouldn't work. Yeah, see, it's just a bunch of junk. So let's go ahead and save our file. And save output. Yep. And a lot of times CyberChef will tell you what kind of file it is when you're saving it. So there we go. Saved. So already there. There we go. So we have our file saved. Let's unzip it. And we have a lot of results, particularly with the AppData folder, right? So if we're not sure what that is, we could just Google what is the AppData folder. Includes application settings, files, and data unique to the applications on your Windows. So it's just the applications to your Windows system, right? So, and if you haven't guessed by now, challenge called Chrome. So we're definitely dealing something with Chrome, right? The whole scenario is that someone stole the files, which we see using the program, and we're trying to kind of reverse what they could have taken, right? And if you're at this point, actually before I move forward, let's go ahead and use solve this using Ghidra. I'm gonna make a directory called Ghidra. I'm gonna run Ghidra. You could just Google like Ghidra install. It's pretty straightforward to install. I'm gonna start a new project, non-shared. It's already there. Finish. Load it up. There's a debugger here, but this one we're just gonna load. And I'm gonna do file, import file, and I'm gonna do transfer exe. Yes. Yes. Select auto analyze, apply, analyze, and it's gonna pretty much fail immediately because it looks like Ghidra doesn't do too well these kinds of files. Typically, what I like to do is search for strings right off the bat, see what it stands out. This one doesn't have a lot of output. But if you will pick up on something, so there's two things you can pick up on. If you're going through the strings, you will see set get IV, and eventually you'll see set key, and those are two indicators that we're dealing with AES. But it doesn't give us all the strings, as you can see. There's some stuff missing. You could Google what these are, but where does it get these strings from is the next question. So typically the next step for me would be to go through the functions, but no function show. Main is not existent here. So I always like to check out imports, exports, and if you made your way through labels and kind of check these, you will land on strings where you see the same messages. So get IV, set IV, and if you keep scrolling down, eventually you'll see AES. So now we know we're dealing with AES, but are the keys hard coded in? You see the key. If you kept scrolling down a little bit, let's see, where is it? Is it coming? Probably missed it. Let's see. Oh yeah, I think I missed it. Alright, so where are you? Let's see. Maybe I went too far. Let's keep going all the way down. So I'm in set key. This is going to pop up here? No. Oh, it's not showing here. That's interesting. Oh, there we go. Okay, I guess I was just in two different places. So if you clicked on US, not only do we have this here, but we also get these string values folder. So file encrypted. So these two right here, if we copy, just paste it here, we have the key, right? And a good way that I always like to check, character count. So for example, let's go back to CyberChef. Character counter, 32 characters, right? If you go to AES, tells you that the different bytes for the key, 32, 24, 16. This one happens to be 32. And if we look at this string right here, copy, this is 19, gotta remove that. This is 16, and typically the IV is also 16. CyberChef tells you that. Let's see. So let's put this in here. UTF. See? IV 16 bytes. You could just add a bunch of zeros, but so that's two ways you could have found it. But as you can see, this way requires a little bit more guessing. Right? You have to kind of go through it, have some patience, kind of figure out, okay, these look interesting. You know, where DNS Spy was pretty straightforward in terms of the approach, just kind of gave us what we wanted, right? And it was a simple code. So that said, I'm going to go ahead and remove this, and let's get back to it. So now we want to get to the bottom of this Chrome, right? So if you Google something like decrypt Chrome passwords, you should get two results right off the bat, and this is where the challenge was inspired from. You get this code, and you get this article, which is also the author of that code. So you think it's safe. So pretty much the code talks about how you can decrypt the passwords of Chrome, the files that you need, the encryption key stored in a JSON file, which is found here. Okay, shows you how it is. It also goes into stores the password in login.data, and then it just kind of goes through decrypt, and it talks that it uses AES, so we're still on the AES topic, right? It goes over decrypt safe passwords, and then the results, right? And it also goes back to the GitHub page. If we look at this code, it's a lot going on. It mentions those two files, right? Gets the secret key. So it's pretty much the script that he uses. And a couple questions I have is, how does Chrome, if you go through the code, there is one thing that should be helpful. So it doesn't decrypt anything less than version 80. So if we Google something like Chrome version 80 AES decrypt function, this article by Hot Hardware that talks about starting with Chrome 80, the browser encrypts local passwords and cookies in Windows using AES 256 encryption, right? And then this kind of confused me a little bit, but this mentions browser leverage the data protection API or DP API that's built into the US to handle the chores, right? So I got curious. If you got curious about that, and I look it up, and a good place that has this information is Hacktricks. So we can. So it's utilized in Windows for the symmetric encryption of asymmetric private keys. Okay, and then protected data by the DP API is passwords from shared folders, Google Chrome's passwords right there. And if you go down, we need the credential files, which are located here. So let's go there. Let's actually folder. So it is in AppData, roaming, Microsoft Protect, right? And we can check that here, roaming Microsoft. Let's see, master keys. There we go. That's what I meant. The credential files, we kind of know that already, but excuse me. Let's see. We have the user's RSA keys. They're stored under here. So let's go ahead and check that out. Okay, so how do we extract that? How do we extract the password? We need that, right? So we could do, and one way, if you look that up, there is a code for John that actually decrypts this for us. So I'm going to go ahead and use that. Let's see. And I think it's, there we go. So if we try to run it, I need to install the Pycrypto package. Pycrypto. All right. And now we can install it. So John, what do we need? Need the page, so the SSID, and then the master key. Okay. So SID, and it's gonna be, I already have it here. Oh no, I want that right there. And we need master key, which is this. I think context. So context. Sure, I don't misspell it. Equals local, and we have a hash. So let's go ahead and save that hash, and let's crack it. See what we get. Right away we have the password. So now let me go ahead and save that. Bubbles. So pretty weak password of the user, right? So now what do we need? If we go back to the article, it does give us a pretty big clue as to what to do next. All right. Let's see, if we go back up, as mentioned before, we need this file, the local state, right? And we actually have that handy. Where is that? AppData local Chrome user data. Okay, so we're gonna need that. Let's copy everything that we need. So I'm actually gonna need this file later. So I'm gonna make their files. Copy. Oh boy. All right. I think it was AppData, roaming, Microsoft Protect into files. And now we need AppData local Google Chrome user data. Okay. AppData local Google Chrome user data local state files. Let's look at there. What else do we need? We're gonna need, it also says we need the default login data. Okay. User data, default, login data, files. Okay, so we have everything. Now, at this point, I actually have a working script, which is a modified version of the original one. Chrome. And what I did is, if we examine them, it really just differs in a few places, but not a lot. So if we look at this get secret key, I just converted that into its own thing so that I can run it right on Linux. Right? Just have to change that. And I got rid of a lot of these libraries. Well, that's not for this one. And if I look at the other script, no wait, that's mine. That's that one. See, the only thing I did is, this is the file we're gonna need. And then just remove a lot. I don't even think I need this. Everything else stayed the same. This changed as well a little bit, right? Because this one thing I did is I didn't just put action URL, so it could be this. and then everything else the same, right? I think this one does like a CSV file, or this, I only need this file. So I'm gonna go ahead and clone this. And I honestly think that's all I need here. So git clone Chrome. So files, I forgot which one I needed. I think it was local state. Local state, okay. So let's change this. This code's pretty straightforward. There we go. Just opens this file, loads it up, looks for these two parameters, these two dictionary values. It decodes it, and then it writes it. Now we have a brand new file. So I'm going to actually copy this to that, right? And now we need, so I believe I have everything. Files. Because I'm going to need, I don't need this, I'm going to need this later, but I'm going to need these three, right? This one, and this one. So let's set up another Python server, and we're going to move over to my Windows machine. And this is where, again, it differs. This gets a little complicated in Windows, but it's not too bad. It's actually a bit easier on Linux. So this is the middle point, the fork in the road, and I'll show both ways. So first I'm going to show Windows, and then I'm going to show Linux, right? And the different tools and how you can get it set up. So back on my Windows machine, we don't need this anymore. And let's see. I'm going to actually turn off my Defender. I don't believe I need to, but I'm gonna be using Mimikatz, and because of that, Windows just does not like Mimikatz for obvious reasons. Mimikatz, GitHub, not by ParrotSec. There we go. GentleKiwi, releases 7C. Gonna extract here. There we go. And I don't need this anymore. You know, I'll just keep it just in case. And now, I don't know why I did that. So there's Mimikatz. So I'm actually going to open PowerShell here. Actually, no, what am I doing? I can make this easier on myself. So I have to download a bunch of files. 3 files really. So I need this, I need this, and I need the login data. Close that. And now if I go back here, I'm just gonna copy these. Oh, this, and this. Not big over here. And now I'm actually going to start an admin PowerShell. I need this. I'll make this bigger. Users, there, desktop, file drops, x64. There it is. Beautiful. So, first thing we need is we need to decrypt the master key, right? So it's gonna be, let's see, Mimikatz, right? And we're gonna do DP API blob, and we're gonna do this file right here. Let's see. Actually, no. What am I doing? Master key in. We need this. sure I don't mess this up. SID, I do need that. I forgot all about it. Let's see if I can get this quickly. Let's see. 1 second here. There we go. There. So, I think I messed up here. There we go. And we need the password, which we already know. Password. Protected. Exit. And I definitely messed something up. It's not password. Whoops. Bubbles. Aha. And we have this key right here. That's the decrypted key. So now we're going to decrypt the blob. Let's see. Delete a bunch of this crap. So DAPI blob master key. Okay. And we need the decrypted key. There we go. And what else? And now the file that we need, which is blob and I believe and out, and I need now the secret key. This is I'm decrypting this now. All right, and we need the key for that. So secret key. And let's see, we have it. Perfect. So now let's go ahead and copy this over here. Now I need my code. And let's see. Let's make sure I still have you on the Windows one. Let's see. Make sure I get the right code. So, actually, let's get that code again. That's just a quick copy paste. Let's see. Chrome. Can't spell. There we go. Now we need this. Raw. One thing I wanted to point out, I did give credit's due. That's the original story. Minimize this. It's going to do new file, decode, get Chrome password. Copy. That's it. Save it. So we need to install this. I don't believe I need this anymore. But let me see. Terminal, new terminal. So I need pip install Pypykatz. There we go. That installed. And I believe that's all I need. Yeah, see, there it went away. So we need a secret key. For some reason, I'm not entirely sure why. I need to select the full path here. If I run it without it, it will fail. So I'm gonna go ahead and fix that. Desktop, file drops, secret key. I'm gonna copy this and I'm gonna put it here. In data. And let's see if this works right out of the box. Python, get Chrome. I don't get anything. Why is that? So, reason is simple. It is the origin URL, right? And I'll show that quickly. let's see. Let me just bring you back over. So there's a lot of different things here. There's origin URL, action URL, username value. So if one doesn't work, no, first building this challenge at least, I remember it didn't work, and I'm like, what did I do wrong? And it was because it wanted a different parameter. So let's go back to that, and that's something I made a note of. There we go. You also could just select all values, but we want those specifically. Let's run it again, and there we go. We have the URL, username, password, and in true form, this is what the attacker essentially could have done. Most likely why they targeted the AppData folder. Figure I'm going to steal it, and I'm going to go ahead and recover all these passwords, right? And that's pretty much how you do it in Windows. So let's go back and switch and solve it in Linux. So it's actually pretty straightforward here. So I'm going to call this Docker run. I'm going to use Pypykatz, which is the equivalent of Mimikatz, right? So let's see. First thing is first, I'm going to create a Docker file. And I'm going to need Python 3.7 Buster. You could do any other ones, Alpine, Python, but I just like this one. It's an older version, which whenever I have issues with Python, especially newer versions trying to install some hack tools, a lot of times it just fails on the newer versions. Another thing I'm gonna do, I'm gonna make this easier on myself. Local state, login, login data. Whoa. Oh, okay, there we go. All right. So I'm gonna copy. I need this. So I'm just an older version. I can never install Pypykatz out of the box. A lot of times it's because of Python issues. So go back to an older version where I know it works and install everything cleanly, and that's pretty much it. It has worked for me ever since. So I'm going to make my work directory PyPy. I'm going to copy all the files I need. Local state here, and login data. So I'm copying all the files into the Docker container. Then I'm going to run pip install Pypykatz. And I'm just emulating the steps here. Pypykatz, install, we need these. So do that. And because I'm installing Python, I can run pip, no problem. And I probably should have kept that open. See, I think it's Pypykatz GitHub. I believe I need all this. So we have that. Let's do this. Yeah, all right. I think that's all I need. So I'm going to run sudo docker build pypy. I'm going to build it here. And if that command is successful, I'm going to run it. ITD attach pypy. I'm going to run that. Okay. So that's my Docker run. I'm going to access this in my Docker exec. Sudo docker exec ti. I need those two. I'm going to do bash. So I just need. So it's going to take a second. But essentially, Pypykatz will give us almost everything we need. It'll give us the passwords. We'll still need the URLs, but that's pretty easy to find. So there we go. Downloaded everything I needed. Copying the files, installing, and then It should go through smoothly. Okay, yes, that's want me to run pip as root, and there we go. So that's our Docker container ID. We just need the first two, 43, and there we go. Oh, and there we go. There's everything. So first things first, we're gonna do Pypykatz, DPAPI, pre-key. So we need the pre-keys. And we're gonna do password. We already knew, kind of easy to remember. We need the SID. Think I password. Think I messed up the order. There we go. So you're gonna go through these. The first one should work. DPAPI master key. I'm gonna output that to a file called mkey.json. Need the master key, which is etc. Yeah, and then we just try the pre-keys. And the first one should give us what we need. Okay. And then now for the final touch, DPAPI, Chrome, login data, and do mkey local state. And there we go. We have the user and his password, no URL, and the both passwords, no URL. No. Well, what do we do now? Well, one thing about the login data, let's see, do I have grep? Is that only the passwords are really encrypted, as you can see, but the usernames are not. So the URLs are here and their respective user IDs. So that pretty much does the challenge. So we're able to kind of go back and emulate what an attacker was doing. So the only thing we're able to see on the traffic was that the attacker transferred files over, right? 2 files in particular. Reverse the files, reverse the binary 2 different ways, one easier than the other. And then we saw what they were most likely after. And we saw that an attacker could have, of course, extracted those Chrome passwords and the websites they belong to. So we definitely have proved the possible actions on objective. So anyway, feel free to like, comment, and subscribe, and I'll see you all next time.